So let's have a look at a typical question. So calculate the standard enthalpy change for the reaction given below. So this is ethene reacting with hydrogen gas to give ethane. With this, you may be given some information, and we are here. What we're given is combustion data. So the information is the energy released when ethene is combusted, when hydrogen is combusted, and when ethane is combusted. Okay, so the way that we would set this out is to write the equation out. I know it's already written there, but that may be within the exam question itself. So if we write the equation out, C2H4, it's a gas, and hydrogen, which is also a gas, and they are our products, reactants, and they are going to give us this product of ethane as a gas. We will write delta H over the top of it, because that's what we want to work out, the enthalpy change for the reaction, so the enthalpy of reaction. Now we're given combustion data, so basically if these are burnt, what will they form? When ethene is burnt, it's going to make carbon dioxide and water. When hydrogen is burnt in oxygen, it's going to give us water. When ethane is burnt, it's going to give us carbon dioxide and water. You can balance this up. I don't tend to balance this up, but you can balance this up. So if this were to burn, we would get 2 moles of carbon dioxide and 2 moles of water. If this burnt, it would give us 1 mole of water. So we would have this. Okay, so we can balance this up. If we burn this, we'd have 2 moles of water, and that would be 3 moles of water. So it's 2 moles of water for that, 1 mole of water for that. So in total, that makes 3 moles of water. Okay, so these are our intermediates. Now, which way are we going? It's combustion data, so we're burning it. So we're going in this direction. And what are we doing with this? We're burning this, so we're going in this direction here. Okay, so what we can do, we can put the information on these arrows that we've been given. So if we burnt C2H4, we would get carbon dioxide. We're only burning 1 mole of that, so 1411 kilojoules for the 1 mole that we burnt. The hydrogen, we're burning hydrogen. We're only burning 1 mole of hydrogen, so that is minus 286. So there is only 1 mole of hydrogen there, which will give us 1 mole of water here. On the other side, we're burning ethane, and we're only burning 1 mole of ethane here. So from this data here, it's minus 1560 kilojoules. Okay, so what I want to look at is I would like to go around this circle. If I'm just going to follow the arrows, I'm going to start at a point where I can follow the arrows round, and I can follow the arrows round here to this point here, and starting at this point I can follow the arrows to here. So if I follow this around, and I can also follow this around, I can then use that green arrow to work out my enthalpy cycle. So starting from here, then delta H minus 1560, that gets me to here, is the same, or is equal to, coming from here down here, so that's minus 1411 minus 286. Okay, so we can rearrange this. Delta H is minus 1411 minus 286. If I take this to the other side, it becomes plus 1560, and we can work that out to give us the answer, which is minus 137 kilojoules per mole. Okay, Hess's law states doesn't matter which way round the cycle you go to get from reactant to product, the answer, the enthalpy change will be the same. So we're working this enthalpy change out, and again I'll just remind you that we're going from reactants to products. It doesn't matter which way round we go, this change, this enthalpy change, will always be the same.